Right. So we're looking in our series on intermolecular forces. We're continuing on, and this video focuses on the idea of hydrogen bonding. And I have a couple of compounds here, and I want us to look at which one of these compounds would we expect to form intermolecular hydrogen bonds in the liquid state. We can look up any structures that we may require. So we need to remind ourselves of what does a hydrogen bond mean. So hydrogen bonding happens if and only if there is NO or F bonded with a hydrogen, and there is a clearly, nicely polarized bond of that can then allow for the acceptance of sort of a pathway for the hydrogen to add to some lone electrons on something on the electronegative element of a different molecule. Okay, so let's draw these molecules that we have here. So H2Se, so dihydrogen selenium is going to be something like Se H. H2. We can see it doesn't contain NO or F, so it's not relevant immediately. So we can just put a cross through that. We can also immediately eliminate HI as an option because it doesn't contain anything that will form hydrogen bonds. So the formic acid and the acetone are the ones that we need to consider. So formic acid, you can go look up the structure and you will see fully drawn out, fully explicit, it looks something like this. This is a formic acid. And then the acetone is C double bond O. Right. Now the question is, which one of these complies with the fact that it has a OH bond that is polarizable and then hence can form an interaction, or not polarizable, but has a polar OH bond or polar NH or FH or whatever bond. And we can see that the formic acid has that situation. It has an OH. Though it seemed from the acetone that there were H's and there were O's, these aren't connected in any useful manner. They're connected to the carbons, and this is not going to lead to any use for or any hydrogen bonding. The hydrogens that come from the other acetone molecules, if you have another one here with the C there, the C and the C go in there, it's not going to do anything there. We'll be back, but in principle, what you're looking for is something that has an extremely, not extremely, but is more polarized, that is almost starting to behave like a proton. And then it links up with something that is on the opposite side again. So there's oxygen wants to grab a hydrogen from one that's bonded to another oxygen in another molecule, and so on. Not something like this, where hydrogen and carbon are very happy to form a covalent bond, very nicely bonded. Oxygen and hydrogen, very polarized, and allows for this hydrogen bonding interaction to occur. So basically, our point here is that here there is hydrogen bonding, and in the acetone case, there is also no hydrogen bonding. So to answer it, say which of the following compounds would you expect to form intermolecular hydrogen bonds in the liquid state? The only answer is the formic acid to form hydrogen bonds. Okay, so that's an illustration of, even though something might contain oxygen and hydrogen, it's not necessarily that it will form hydrogen bonds. it has to have that OH bond that is semi-polarized or still polar, and then that will allow for the hydrogen bonding interaction to actually form. Okay, thank you for watching, and I'll see you in the next video.